This week we're going to look at feedback mechanisms. Okay, feedback mechanisms are used to either amplify certain processes or maintain an equilibrium with those processes. All right. So we'll start off with positive feedback. Positive feedback is when you have a stimulus. Okay, and that stimulus will make a response, and that response will increase the stimulus, which will increase the response. For example, Susie, good job on your work, keep it up. And then because of that little positive stimulus, she increases her work, and then I'll say, hey, great job, keep it up, and so all of a sudden you get an amplification of that effect. Okay, so it happens in your body and it happens in the world. Actually, let's start down here with global warming. It's a good example. There's a thing called albedo. Okay, albedo is the percent of radiation which is reflected back into space. Okay, so for example, polar ice caps. Traditionally there's a lot of snow up there, so it reflects a lot of light. So we would say I have a high albedo up in the with snow. Okay, but here's what's happening with global warming. Okay, you're just going to get increase in heat. Okay, caused by maybe greenhouse gases. But you start that process, you get a little more increase in heat. What that does, it decreases the amount of albedo. Okay, so you have more radiation being absorbed by the Earth. Okay, which is then of course going to cause an increase in heat. Okay, which is then going to cause more melting from the ice caps, which is going to cause a decrease in the albedo, and you can see then that process can then just amplify out. In this case, probably not in a good way. All right? Within your body, you have some positive feedbacks. Good example would be blood clotting. Okay, that's in a good way. You want to amplify that process of the platelet formation. Okay? Another great example is during childbirth. Okay, so amplification of the process. So you have my beautiful little baby here. So your baby in the uterus. So this is the uterus, my uterus, and then that opening right there is called the cervix. Okay? So as the baby gets bigger, it's ready for childbirth. The head starts to push against the cervix. Okay, so baby head pushes on the cervix. The cervix stretches. And in response to that, it sends nerves to the brain, and the brain tells the pituitary to release this hormone called oxytocin. Oxytocin then goes down into the uterus and causes an increase in uterine contractions. And that causes the baby head to push on the cervix more, okay, which then causes the cervix to stretch. There's the brain, and you can see that would be a positive feedback loop. Okay? So in that case, it only stops after the baby is delivered, and you can have relaxation there. Okay? That's positive feedback. The other feedback mechanism is negative feedback. Okay, so negative is not necessarily bad, okay, but it's for keeping things at an equilibrium. Okay, so that's termed in biology as homeostasis or internal equilibrium. The key master gland for that control is pituitary, and it has interaction with the nervous system through the hypothalamus. Okay, so this is going to be one example from the pituitary, but you have multiple examples. It releases a lot of hormones. Basically, how it's turned on and off is from the thyroid, which secretes a hormone called thyroxine. Thyroxine is responsible for your metabolism in your body. Okay, so keeping your metabolic rate up. Okay, so if you have a hyperthyroid, you'd be kind of anxious and burning a lot of energy. And if you have a hypothyroid, then you'd be kind of lethargic and slow and so forth. Right? So in this case, pituitary secretes this hormone called TSH, or thyroid stimulating hormone. And it goes down to the pituitary. So pituitary is in the down to the thyroid. Pituitary is in the middle of your brain. It goes down to your thyroid, which is right here. And those cells in the thyroid will then secrete this hormone called T4, which is thyroxine. The 4 is for the iodine. There's a little iodine molecule in there. Okay, and then it goes throughout your body because the target cells are all throughout your body, and it causes the metabolic rate to be constant. Okay, but it also goes then back to the hypothalamus. So if you have high levels of thyroxine, it will then shut down the hypothalamus, which will tell the pituitary to stop secreting TSH, and therefore these levels then eventually will go down. Okay, and if you get too low a level, it will turn the hypothalamus on. It'll release a releasing factor to tell pituitary to turn back on. And that way you maintain a constant level of thyroxine or T4 in your bloodstream. Another great example is your sugar levels in your bloodstream. Okay, of course, your brain has to have sugar at a certain level. Okay? I think it's around 80 to 120 milligrams per milliliter. Doesn't matter, but it needs to be constant. If you get sugar levels too high, you go into what is called diabetic coma. And if you go too low, you go into insulin shock, which means you can die from that. Okay, so your body wants to keep that in a equilibrium. Okay, so over here, here's how it works. If you get high glucose in your bloodstream, so for example, you eat a lot of candy around Halloween or sugar from a soda pop, okay, your pancreas will read that. Your pancreas is in your abdominal cavity, okay, and it will secrete insulin, okay. Insulin gets in your bloodstream and goes throughout your body, and main thing it does, it goes to your liver, okay, and it goes into your body cells, and it causes an uptake of glucose, okay, from the bloodstream into your cells. Right? So if you eat too much sugar, okay, it gets into your liver can store so much, and then the rest gets taken up by your body cells, and your body cells can convert that into fat. So just by eating sugar, you can get fat. Okay, but what that does, it takes the sugar out of your bloodstream, okay, and then it goes back to the pancreas, back down to the lower levels. On the other hand, if you get too low glucose, okay, glucose levels drop down, your pancreas then secretes a different hormone called glucagon. Okay? Glucagon goes to your liver where you have excess sugar stored up in the form of glycogen, you remember, and liver will then cause the breakdown of that glycogen into glucose, so it'll increase your blood sugar levels, okay, and then that'll go tell the pancreas to stop producing glucagon. So those are good examples of negative feedback. One more good example of homeostasis or internal equilibrium. All right, so we're going to talk about thermoregulation. Right? Our body's temperature is 98.6, which is 37 degrees Celsius. All right? So what reads that is a hypothalamus. So hypothalamus actually is the middle of your brain. It's going to read the temperature of the blood returning to it. Okay, then it does one of two things. If it's got too low a temperature, okay, of course this is your brain here, brain stem, middle of the brain, you have that hypothalamus. Okay, it's going to send nerve signals to your blood vessels to constrict. Okay, that's why blood vessels constrict, especially in your extremities, which will decrease the amount of blood to the skin layers, which of course is going to decrease the amount of heat loss. So you would tend to become a bit pale, fingers turn kind of whitish when you get really cold. Also cause your muscles to shiver. Okay, you shiver, and of course that causes movement, but of course you guys know that most of that energy is converted into heat. So that helps warm your body up, right? So you increase the temperature, it gets up to 37 degrees, then it will then turn off, of course. Okay, on the other example here is if you get too high a temperature, so you start to overheat a little bit, again you tell your hypothalamus, and the hypothalamus then will send nerve impulses to your blood vessels, and they will dilate. Okay, so you will kind of get kind of a flush or a reddish color to you because you want to dissipate that heat. Okay, so that allows heat to leave your body. Okay, and then of course it causes an increase in sweat. Okay, so it goes to sweat glands, which release sweat, which of course is a cooling process. You guys know water has a high specific heat. Okay, so when it goes from being a liquid to a gas, it takes heat away from your body. So for that sweat to evaporate, it's drawing heat away from your body, which of course is going to cause you to have a decrease in temperature, okay, hopefully back to the 37 degrees. Okay, so you're able to keep that 37 degrees because of the hypothalamus and this homeostasis it produces.